Lesson 3. So we're going to be multiplying and dividing radicals. So if you guys can just turn to this page and just like write down what I'm writing on this one, just kind of like a blank spot for you. Okay, so then we're going to have something like 3 root 2. Okay, so multiplying radicals. Okay, so I'm just going to pretty much go through some examples, just going to show you. So we can have something like 3 root 2. And then you might see it like written a few different ways, right? It could be written with brackets, something like that. So 2 root 5. It could be written with brackets. It could be written with like a little dot to show. It could be written with like a multiply. Like, multiplying can be like shown a lot of different ways, right? So all we have to do for this one is just the numbers out front. The numbers out front are multiplied by the numbers out front. And the radical is multiplied, or the radicand is multiplied by the radicand. And that's pretty much it. So we're multiplying, it's pretty straightforward. So numbers out front, the coefficients would be 3 times 2, right? So this would be 6, right? So this one times this one. And then the square root would just be 2 times 5. So 2 times 5 is 10. But it's still under the square root. That makes sense? Okay. So that's the gist of it. We'll just see it a few different ways here now. So let's say we had a question like this where it was, let's do 4 root 5 times, and then now let's say 3 root 2 minus 4 root 5. So now what we have going on is we have a monomial, right? 1 term times a binomial, 2 terms, right? 2 terms. Right, so when I'm multiplying these, do you guys remember how to do this one? What do you do when you're multiplying like this monomial times? It's the rainbow thing, right? It's going to be this one times both. It's going to be times this one and then times that one, right? So same as before. It's not any harder. We just do 2, right? You've got to do this one and then this times this. So there's 2 things going on. Okay, so let's do the first one. So we've got 4 times 3, so numbers up front, so this is going to be 12. And then 5 times 2, so root 10. And then just move on to this. So 4 times negative 4, right? So 4 times negative 4 is negative 16. And then 4 root 5 times, or sorry, 5 times, or root 5 times root 5. This one gets everybody all the time. What is root 5 times root 5? There's 2 ways to think about it. Let's even like write it up here. So if I had root 5 times root 5, well, like what I said before, right? This would just be 5 times 5. This would be square root of 25. What is the square root of 25? Just 5, right? That'd just be equal to 5. Another way, probably a simpler way of thinking about that, is if I had root 5 times root 5, well, that's the same thing as the square root of 5 squared, right? What happens if you square a square root? Yeah, they annihilate, right? They go away. So I got a square and a square root. So this is just equal to 5. So if you've ever got, a root multiplied by itself, right? Like square root 5 times square root 5, it's just the number underneath. It'd be just 5 in that case. So when we do this one, it'll be 16 times 5. Okay, so then in the end, I've got 12 root 10 minus, and then 16 times 5. 80. Because we knew what the square root was. Like you're talking about here. Why didn't we leave it as a square root? Because we didn't need to. Because square root of 5 times the square root of 5 was just 5. Just a number 5, right? So we don't need a radical there anymore. So we can write it as an actual number at that point. And then this is my answer, right? Like that. It looks weird, right? That doesn't seem like an answer, but that is my answer. That's. And why don't I just type it in my calculator now? Why don't I just go 12 times root 10 minus 80? Maybe I'll coach you on this one. I won't do that because that won't be an exact solution. Because because of the square root of 10, I'd have to round at some point, right? This is an irrational number that even number is going on forever. This, the way it's written right now is like as exact as it could be. It's like perfectly exact. Yeah. So you get a decimal that you have to round, and then a bunch of numbers, right? That you have to round. Yeah. So we leave it like that. Okay. So let's do another example. So let's do a tougher one. I'll go root 3 minus 2 times, let's go root 3 plus 2. All right, so now we've got a binomial times a binomial. So you guys remember how to do this one? It's FOIL. You guys remember FOIL? There was like first, right? That's like the F. Outside, inside, and then last. So FOIL, right? But really what it is I just need to multiply this root 3 times both of these, and then this negative 2 times both of these. That's really all that's happening there, right? So just we're going to have 4 different terms when we're done here then, right? And then we'll have to collect like terms at the end. So we've got root 3 times root 3 would be what? Just 3, right? Just the number 3. We just talked about 3. And then root 3 times 2. I can't really multiply those, right? They're different, like one's a coefficient and one's a root. So all I can do is just say, well, that's 2 root 3. And then on to my inside. So now I've got negative 2 times root 3, which is negative 2 root 3. All we can do. And then finally, the last, so negative 2 times positive 2 would be negative 2. Okay, so now I can collect like terms though, right? These guys are like terms, they're both root 3. So I've got 2 minus 2. What's 2 minus 2? 0. So they're just gone, right? I could say 0 root 3, but that'd be 0. So they're just gone, they cancel, right? 2 minus 2 is 0, they're gone. So what I have left is 3 minus 2. In the end, my answer is just 1. Okay, good. Let's do some divide. Dividing radicals. It'll be really similar. So we're going to say, let's go like square root of 6 divided by the square root of 2. It's going to be really similar here, where radicals by radicals, right? So in the end, this would just be, so 6 and 2. What is 6 divided by 2? It's 3, but then you've still got it underneath the square root. Okay. Now, if we had numbers up front, that could be like 4 over 2, or sorry, let's go like 4 root 9 over 2 root 3. Okay, numbers by numbers, roots by roots. All right, so 4 divided by 2 is what? 2. So this is 2. 9 divided by 3 is 3. So it's still in the square root. So very similar, right? tough. I'm going to make it a little bit tougher on you guys. So there's one case here though. So let's say we had 2 root 3 over root 5. Now we can say 5 root 5. Alright. I can't really divide anything here, right? Yeah? So you'd say, like, you probably think, well, I can't do anything. Here's the thing with radicals. We don't like dividing by an irrational number, right? It doesn't really give you a very nice number. So what we're going to do is we need to, here, be right from the bottom. We need to rationalize. Rationalize the denominator. And what I mean by that, rationalize the denominator means don't have a square root in the denominator, in the bottom, right? So that's what we're after. So there's a little trick here that we're going to do to get rid of the square root of 5. So the little trick that we're going to do is we are going to, remember how I said if I multiply the square root of 5 times the square root of 5, the square root would go away, right? That would just become 5 in the bottom, right? But can I just go around like multiplying by this, or multiplying in the denominator by the square root of 5? No, that changed the equation, right? So what I'm going to do is I'm also going to multiply the top by the square root of 5. And the reason why I'm doing that is because what is the square root of 5 divided by the square root of 5? What does that equal to? Square root of 5 divided by the square root of 5? 1. Yeah. What is anything divided by itself, right? It's just 1. You could have like a million divided by a million is 1. You can have y divided by y is 1. Like anything divided by itself is just 1. So the fact that I like multiply this thing by square root of 5 divided by square root of 5, it's like I just multiplied it by 1, right? I didn't change anything. I just made it look a little different. Does that kind of make sense? Okay. So when I do this now, right? So I'm going to multiply, I'm going to do the top, and I'm going to do the bottom. So we're going to go, okay, 2, right? 2 root 3 times root 5. Well, that's just going to be 2, right? Because there's no number over here to multiply it, right? So it's just 2. And then what's root 3 times root 5? Yeah, root 15. And then on the bottom, I've got just 5 again, right? That 5 is still just there. And then what is root 5 times root 5? Just the number 5. Okay, so that's just 5 times 5. And then finally, you'd actually just multiply those 5s in the denominator together. So this would be 2 root 15 divided by 25. Yeah? All right. That's, if you guys change to the next page there, we'll do one of these together. Okay. So let's do 7. So again, like I'm dividing these guys, right? I can't really do anything with the top, right? There's nothing I can collect like terms. There's nothing really here I can do at all. The only thing that I can do is deal with this like square root of 6 in the bottom, right? I need to rationalize it. So the way I'm going to do that is by multiplying this thing by square root of 6 over the square root of 6. Right? Because in the bottom, that square root of 6 times the square root of 6 is going to get rid of the square root. I'm going to rationalize it. Okay. So now, the top, it looks a little bit different here though, right? We now have on the top here, we've got this binomial on the top multiplied by this monomial, right? The way I was doing it, it would have looked like this, right? Root 6 times root 2 plus 4 root 3, right? And then you distribute that way. That's the way I had done it. But it doesn't matter, that's on the other side. You just have to multiply it by both of those as well. So root 6 times, I'll do this one first. Root 6 times root 2 would be root 12, 2 times 6, plus 4, and then root 6 times root 3 would be root 18. over, and now here was the whole point, right? Root 6 times root 6 is a big old 6, right? Just struggling today, guys. Root 6 times root 6 is just 6. So we rationalize, right? There's no more irrational number in the denominator. There's no more square root. Okay, so that pretty much is it. But if we want to be, not picky, but we want to be as simple as we can, I can break down this 12 and I can break down this 18 to make it a little bit simpler, right? Square root of 12, I can take some stuff out of that, right? What can I break 12 up into? What perfect squares go into 12? Yeah, I could rewrite this as 4 times 3, right? This 12 is 4 times 3. And I can rewrite the 18, right? So this is 4. So instead of this root 18, what could I rewrite 18 as? I could do 6 and 3, but neither of those are perfect squares, so it doesn't help me. What perfect square goes into 18? 9 and 2, yeah. 9 and 2. And that's still all over 6, right? Okay, so very last thing, this 4 gets to come out as a 2, right? Square root of 4 is 2. And this 9 gets to come out as a 3. That comes out. So we'll just do that now. So this 4 comes out as 2 root 3 plus, okay, so now this 9, when it comes out, it's going to come out as a 3. So 4 times the 3 that comes out, right? That's going to be 12. Root 2 all over 6. This 9 right there, right? The square root of 9 is 3. So the 3 came out and it was multiplied by the 4 that was already there. Okay? And then I would be good with this. I'd give you guys the marks for this. But technically, we could make it a little simpler. So the way we could do that is because there's something common in the top and in the bottom. We could cancel some of this. And the best way to do that, do you guys remember from grade 10C, do you guys remember factoring? Like how we could say what's common to this term and to this term? Maybe. If you don't, that's all right. So what we're going to do is say what's common to this term and to this term. What goes into both? Well, 2 goes into both, right? They're both even numbers, 2 and 12. So I could factor a 2 out of it. So I've got 2, and then you start your bracket, and then you write what you have left. So 2 divided by the 2 I took out is 1, so it's just root 3. And then plus 12 divided by the 2 I took out is 6, root 2. And then this is all over 6. And now the fact that I took this 2 out means I can actually, it's free game to cancel with the 6. So I'm just going to simplify this last part there. So 2 over 6 would be 1 over 3. So in the end, this would all be just root 3 plus 6 root 2 all over 3. It's like 1 over 3, right? That's what that turned into. That last part confused you. We'll do more of that later. But yeah, that would technically be your final answer, would look something like that.
Can you